Hello everyone, welcome to that Biochem guy. So today we'll be discussing about something, a really important aspect where most of the students do lose their marks. So this is gonna be the electrophilic substitution of the benzene rings, right? So this question is of 4 to 5 marks, and most of the students, even without realizing, loses like even more than 90% of the marks in this type of questions. So let me just teach you the most appropriate way for this type of mechanisms, right? So by default, I know that this is a electrophilic substitution reaction, and this nitro group would be, this electrophile would be joining on the fifth carbon, right? So I know that this is carbon 1, 2, 3, 4, and 5. Now you could say that why this is carbon 1, because this is the carboxylic functional group, right? And carboxylic functional groups are by default the highest priority groups. Okay, so basically we'll be numbering from here: 1, 2, 3, 4, 5. So if the electrophile joins over here, then we'll be having this thing, 5 nitro salicylic acid. Okay, now comes the most important part of it. So first of all, the electron from here will be going towards the electrophile. Okay, and once it goes to the electrophile, the ring would become like this, because the electrons are already taken by this thing, right, to make this bond and everything. Now I have noticed most of the students giving this thing is what we refer to as a horseshoe. And this horseshoe should be pointing towards the carbon that is a tetrahedral carbon, where the electrophile is basically joining, right? The electrophile is joining over here, so this entire thing, this horseshoe, should be pointing over here as well, right? Now there's this charge. Okay, the charge should be basically inside this half complete horseshoe, or the cycle, as you could say. This thing basically looks like a horseshoe. So yeah, horseshoe, so they prefer to call this as horseshoe. And yeah, then the electron would be going from here and the circle would become complete, right? This leads to the formation of a nitrobenzene. Now I have watched like most of the students giving their arrows like this or either this. No, the arrow should only be pointing towards that tetrahedral carbon, the carbon where this electrophiles would be joining. This is what we refer to as the tetrahedral carbon. Okay, and the charge should be inside of this incomplete circle, right? The charge shouldn't be over here or something like that. I have found students doing the same thing again and again over the years, and that's why they do lose 3 marks at least in their electrophilic substitution mechanism questions of benzene, which is equivalent to 4 to 6 marks in their UMS thing as well. Okay, now I basically do not need you to trust me on this. Let's just see what the examiner at Excel wants you to do. Okay, so candidates who knew the mechanism of benzene electrophilic substitution experienced difficulties with unfamiliar electrophiles, but often lost marks due to simple inaccurate in sorry so they basically didn't find any difficulties, but they have lost a lot of silly marks due to some simple inaccuracies, right? Now common errors were incorrect placing of the curly arrows, this arrows, the arrow stuff and everything. Okay, this stuff or this stuff, and curly arrows, and placing the positive charge outside the wheel and diagram, right? As I said over here, they place their charge over here or something like this and so on. And outside the and wheel and diagram horseshoe, and often adjacent to the tetrahedral. Just give me a moment. Placing the positive charge outside the horseshoe and often adjacent to the tetrahedral carbon. Okay, and failing to extend the horseshoe over enough carbon atoms. Ideally should be above 5 carbon atoms, but an orienting horseshoe incorrectly, the gap must be okay. In short, first of all, this thing should be at least 5 carbons, 5 carbon atoms of length, right? So see, 1, 2, 3, 4, 5. I mean, the gap should be at least around 5 carbons. Okay, I mean, longer than these or shorter than this wouldn't really matter, but yeah, if I was you, I would be sticking with their point of criterias. Okay, and yeah, and this thing should be facing this, the open end should be facing this tetrahedral carbon where the electrophile would be joining. So yeah, that brings us to the end of the short session. I hope you did love the video. If you did love it, then or if you did find the video to be helpful, then make sure to subscribe. Have a great day, everyone. All the best.